The combination of seatbelts and airbags has saved thousands of lives in the past decade. Every year, the number of car crash fatalities and serious injuries drops, even though the number of cars on the road and the number of collisions increase. And that's good news, because it means that automotive safety components are doing the job they were designed to do. In this video, we'll look at the components in the supplemental restraint systems, how they work, and how together they provide additional protection to the driver and passenger in the event of a collision. After viewing this video, you should be able to identify the components in the vehicle safety systems, describe the operation of a supplemental restraint airbag control module, describe the supplemental restraint system self-test, The airbags are contained in an airbag module. The airbag module includes the nylon airbag, an inflator assembly, and an airbag module cover. The inflator assembly can be either a chemical reaction charge assembly or a propellant tank-based system. The chemical reaction charged assemblies use a solid propellant that reacts with a chemical accelerant to produce a nitrogen gas that inflates the airbag. A propellant tank-based system uses a cylinder filled with an inert gas to fill the airbag. The airbag module cover is designed to break away on a tear seam to allow the airbag to inflate outward. The airbags are secured to the steering wheel or instrument panel using tamper-proof Torx safety bolts. A special Torx socket is required to remove these bolts. Some European vehicles also use a latch that requires a screwdriver to release the airbag module from the steering wheel. The Supplemental Restraint System Control Unit gathers information from input sensors, processes that information, and outputs an electrical signal to the airbags and seatbelt pretensioners to deploy those systems when the control unit has determined that a collision that requires the supplemental restraint system is occurring. The inputs for the Supplemental Restraint System Control Module include crash sensors, G sensors or accelerometers, passenger seat occupant sensors, seat position sensors, seat belt switches, safing sensors, and a passenger side airbag deactivation switch. Accelerometers or G-force sensors are designed to complete a circuit when an abrupt deceleration occurs. Electric mass deceleration switches use the gravitational force to turn the rotor that closes a switch. The closed switch allows current to flow in the form of a voltage signal to the SRS electronic control unit, while other acceleration or G-force sensors use a ball held by a magnet. A rapid deceleration causes the mass of the ball to pull from the magnet and move against the switch contacts. Another style of accelerometer is a signal-generating solid-state G-force sensor. These sensors send a voltage signal when compressed by deceleration forces. Bending beam strain gauge type G-force sensors work much like a beam-type torque wrench. When the force of deceleration acts on the bending beam, it modifies the voltage signal that is returned to the SRS electronic control unit. The SRS electronic control unit determines if the returned voltage is above the threshold value that indicates a collision event. Most accelerometers and G-force sensors have onboard conditioning circuits to filter out false signals. Many current crash sensors are electromechanical devices mounted near the center of the vehicle. In every collision event, at least two sensors must close before the airbags can activate, and the governing sensor, or safing sensor, must be one of the signals to the SRS electronic control unit. The safing sensor, usually mounted inside the SRS electronic control unit, validates the crash sensor signal. when deceleration forces cause it to also close the circuit. Often, the safing sensor is a simple switch, such as a drop of mercury inside an inclined tube which contacts at the far end. When the G-force of collision deceleration forces the mercury to the top of the tube, the switch contacts are connected. Off-road vehicles may also have an additional sensor, sometimes called a discriminator, that tells the SRS electronic control unit if the vehicle is traveling over rough terrain. Piezoelectric and strain gauge sensors are often used to measure vertical bounce and jounce vibrations. When the SUV is off-road, the SRS deployment program is modified by the sensor sending signals to the SRS electronic control unit that prohibits deployment of the airbags from the bounce and jounce of traveling over rough terrain. Some newer sensors also allow for slower bag deployment in off-angle and off-center impacts. The newer side airbag sensors have built-in microprocessors mounted on the sensor. These smart sensors can process accelerometer data and identify non-deployable events such as door slams and door openings into obstacles. A smart passenger side airbag monitors passenger seat occupancy and the weight of the passenger. Other occupant protection systems not only know where all car occupants are, but will detect each person's seating position and modify the supplemental restraint activation accordingly. The output devices activated by the supplemental restraint system control module are driver side airbag, passenger side airbag, side or head impact protection systems, and seatbelt pretensioners. Current systems have 2 or more airbags, additional sensors, plus seatbelt pretensioners. And advanced restraint are even more complex, using smart technology built into the SRS electronic control unit to continuously monitor seat occupancy, including occupant position, weight, and seatbelt usage. In a collision event, the new SRS electronic control unit will make instant adjustments to the elements of the restraint system based on these factors, as well as on crash severity and crash direction to assure optimum protection level. The passenger's airbag module assembly consists of the airbag, the inflator, and the cover that is formed to be an integral part of the instrument panel. The inflator contains a propellant, usually sodium azide and potassium nitrate. On the hybrid-type airbag modules, the propellant combines with an argon-helium gas to inflate the airbag. Many newer vehicles are equipped with side or head impact airbag inflators, which may be a curtain installed above a side window or mounted in the door or seat back. Typically, when the firing circuits of most newer model SRS electronic control units have determined a collision is in progress, the seatbelt pretensioners are activated just before the airbag to position the occupant in the seat and prevent the occupant from submarining under the lap belt. The seatbelt pretensioners drive the tensioning assembly forward and reduce the slack in the seatbelt harness. The reduced slack helps to reduce the risk of injury to an occupant in a frontal accident. In addition, many vehicles also use a seatbelt buckle pretensioner to remove the play in the seatbelt buckle. All seatbelt retractors that use pretensioners have a force limiter built into the retractor to release the tension on the belts after the airbags deploy. A small number of current vehicles include knee bolster airbags that are mounted below the steering wheel or below the glove box on the passenger side. All of the SRS electronic control unit's monitoring depends on harness and connectors that have solid continuity between the electronic control unit and the components located around the vehicle. Which means the wiring and connectors of an SRS circuit, as mentioned earlier, are special. First, all terminals in the SRS connectors are gold-plated to assure consistent continuity. Gold is an excellent electrical conductor, and unlike most other metals, it doesn't oxidize. The terminals are fitted into keyed connectors, so the system cannot be incorrectly wired. An SRS connector can only be joined to its mate. The connectors for the airbag modules have an electrical shunt that prevents unplanned deployment of the airbag should the connector be disengaged. The supplemental restraint system also has a unique wiring harness for easy identification. SRS wiring near the SRS electronic control unit is enclosed in a brightly colored casing. And in most systems, all the connectors in the SRS are also locked in place with a connector lock. The SRS electronic control unit constantly monitors the status of the connector lock lever by sending a small current through its circuit components. If any connector is not properly locked, the system generates a diagnostic trouble code and turns on the SRS warning light. For the driver's side airbag in the steering wheel to work under all operating conditions, it must receive the signal from the SRS electronic control unit to deploy, regardless of the position of the steering wheel. The clock spring is the component that ensures that the driver's airbag inflator is constantly connected to the electronic control unit, regardless of steering wheel position. The clock spring is located directly below the driver's airbag module. The Supplemental Restraint System electronic control module has a capacitor that is used to store enough electrical current to power the airbag modules in the event that battery power is lost prior to or during a collision event. When servicing supplemental restraint systems, it is critical to your safety that you follow the vehicle manufacturer's procedure to discharge the capacitor prior to attempting any service on the system. The supplemental restraint system automatically conducts a system test when the ignition key is turned on. The airbag lamp on the instrument panel will remain illuminated during the system self-test. The airbag lamp should turn off after 5 to 8 seconds, indicating that the components in the supplemental restraint system have passed the self-test. If the light does not go out or goes out and comes back on, then the self-test has detected a problem that must be diagnosed and repaired to restore the integrity of the system. If the airbag light goes out and there is no problem with the system, then the system does nothing until a collision situation occurs. The supplemental restraint system requires that 2 sensors detect a collision prior to deployment of the airbags and seatbelt pretensioners. The safing system must first detect the impending collision and arm the system. Then, 1 or more crash sensors must close the circuit to the supplemental restraint system control unit. The SRS electronic control unit will make a determination if the collision is a frontal impact or a side impact and enable the appropriate airbags and seatbelt pretensioners for deployment. The seatbelt pretensioners are the first devices to deploy. They remove the slack from the driver's and passenger's seatbelt webbing. On vehicles equipped with a seatbelt buckle pretensioner, that device will remove the slack from the buckle latch. Then, electrical current is allowed to flow through the SRS electronic control unit to power the airbag inflators to deploy the airbags. If the vehicle has a passenger presence detection system, the passenger side airbag deployment may be modified to a slower deployment rate. If the vehicle has a switch that allows the driver to disable the passenger side airbag, the switch will open the circuit to the passenger side airbag module, and that airbag will not deploy. If the collision is a frontal collision, the front airbags will deploy shortly after the seatbelt pretensioners. The chemical reaction of the solid propellant system airbag inflators will generate a non-toxic gas that inflates the airbag. On propellant tank systems, the electrical current will allow the propellant tank to open and fill the airbag. Depending on the angle of the collision, the side or head impact airbags may deploy at the same time as the driver's side airbag, or they may deploy independent of the front airbags. Almost immediately after the airbags inflate, they deflate, venting the propellant through the vents in the back of the nylon airbag. As the airbags deflate, the force limiters on the seatbelt retractors release the tension on the belts that was initiated by the seatbelt pretensioners to allow the slack back into the driver's and passenger side seatbelts. This sequence of events provides the maximum protection for the driver and passenger in a collision, while minimizing the potential for personal injury during deployment of the supplemental restraint system. In this video, we have looked at the components in a supplemental restraint system, how they work, and how together they provide for occupant protection in a collision. Thanks for watching.